Okay, as I say before, the distance protection, there is a possibility of having forward and reverse reach. Okay, the reverse settings and the forward settings is the settings that we already discussed for Zone 1, 2, and 3, okay? The reverse setting is typically used based on modern digital and numerical relays, okay? Where you can have Zone 4, 5, 6. Zone 4 is typically used to provide backup protection to the local bus bar. That means that the protection is not looking into the transmission line, is looking backwards, is looking to the bus bar. And if there is a fault over there, this relay will be able to identify, okay? But the way to do this is including the zone number 4, is including the zone number 4, and it's a reverse reach, and the setting is typically 25% of the zone 1 reach. Okay, that is the typical one. That is the zone number 1. However, in this class we will not use zone number 4. However, I want that you understand that modern digital protections allow you to have zone number 4, that can be the backwards or reverse protection, and that can be used for backup protection of the bus bar. Okay, the selection could be a bit more delicate because bus bar protection is a very interesting topic, especially covered with the differential bus bar. But again, that is not included here. We don't discuss that because that is advanced protection systems. Okay. What I will do now is I want to run a short example. I will run a very short example using a step distance protection, okay? Using the classical three zones, okay? What we have over here is a very simple transmission system. And you can see over there are 4 bus bar, A, B, C, and D. And there are 3 relays over there, AB, BC, and BD, okay? My discussion today, it will be focused only on relay AB, okay? Relay AB is located here at bus bar A and is looking towards bus bar B, okay? And all those impedances, they are impedances of the transmission lines, and it's clear that that represents the primary impedance. I mean, that is the impedance coming from the system. Settings of impedance relays are usually expressed on the secondary circuit of the transformers. Okay, however, they are very modern digital protections that you can run the settings already, including without taking in account the transformer. Of course, you need to put the data of the transformers inside the relay, but that is another history. Okay, you will see something like that in my hopefully in my practical classes with the real relays. Okay, that is included in the practical session that is not covered in this module. Okay, okay. Now let's work here. Okay, the sum 1 is typically between 85 to 90% of the lines, and the line that we are protecting is here because we have this relay here. We have the relay looking in this direction, and this is the line that we are protecting. For zone 1, we want to go between 85 to 90% of the total impedance, okay? In this case, we say that we want to go for 85%, and 85% of the total impedance. We put the numbers and we got the setting for the sum number 1. Okay, simple. Then we have sum number 2. The sum number 2 is extremely simple. you can say that is between 120 and 150% of the protect line. In this case, we will go a bit lower. We will define the setting as the minimum, that is 120%, and 120% of the impedance of the transmission line. We get here the setting. Okay. And finally, zone 3. Zone 3 is extremely simple. All my students are able to identify. Zone 3 is very simple because it's 100% of the protected line plus 150% of the next line. Okay? That is one of the criteria. We are using that criteria. That is here, you can see this is the impedance of the protected line más 150 of the next line. Okay, I believe you can see here this is the next line. Okay, and doing so, we obtain the settings for the setting for zone 3. Okay, very simple. There is no problem. Settings like this are extremely simple.